All right, well, with 3 weeks left to the exam, I want to take the opportunity here and answer 7 questions. Questions that I get almost on a daily basis. Questions that I've answered many times over that seem to be the most popular questions with candidates about some of the more tricky issues of when do I do this, when do I do that. So let's begin. Number one, all rates, all interest rates that you see, all rates everywhere are quoted annually. Everywhere. So if we see a 30-day rate at 1.2%, that's not 1.2% for 30 days. That is a rate of interest of 1.2% annually for those 30 days. So 0.012 multiplied by 30 over 360 to get it into a 30-day term, or 0.012 divided by 12. That is an annual rate. If we have a 90-day rate at 2.1, that's quoted annually to get it into a 90-day period, 0.021 multiplied by 90 over 360, or 0.021 over 4. And if we have a 6-month rate of 3%, again, that's an annual rate. Multiply the 0.03 by 180 over 360, or 0.03 over 2. So if you're ever looking at a chart and it says 3-month rate, 6-month rate, those are annual rates. You must divide it by the periodicity to get it into the period of time that you need it. All rates everywhere are quoted annually. You don't have to think about that one. That's just a rule. Number two, for using trees to calculate the value of bonds with embedded options. At certain nodes, we calculate the value of a bond and then we add the coupon on. So if a question says, what is the value of the bond here? The question is, well, how come we're not adding the coupon on? And here's a general rule that we've learned at level 1. The value of a bond at any point in time is the present value of all future cash flows. All future cash flows. For the value of the bond at V1, the future cash flows are the principal and the coupon at the next node. This coupon here is the future cash flow of the value of this particular bond, or the bond's value at this particular node. So this coupon does not get added to the value of this bond. If we're asked for the value of the bond, a value is the present value of all future cash flows. This coupon belongs to the previous period of time, so you would not add that on. If the question asked what amount at this node would be used to discount back to the previous node, then you would add the coupon on. But if it is only asking for the value of the bond at a particular node, the value of any bond at any point in time is just the present value of all future cash flows. Any coupon here belongs to the previous node. All right, the next one deals with periodic pension costs. If a question is asking for the periodic pension cost, be aware that those components can appear on the income statement or in OCI. If it's specifically asking for the periodic pension expense that appears on the income statement, that's a different question. Be careful of that. But if it's just saying to calculate the periodic pension cost, don't be drawn into thinking it just is the income statement. Those costs can appear on the income statement and OCI. And, okay, there's a confusion between IFRS and GAAP. Well, I'm going to show you that the white writing here covers both, that you don't really need to worry about IFRS or US GAAP. You just have to do what I've shown you here. Take your current service cost, add your past service cost, add your full interest expense. Don't worry about the expected return on the assets. Just add your full interest expense. Subtract any actuarial gain or add any actuarial loss, and then just subtract the entire actual return on plan assets. There you go. Now I'm going to prove to you that it's the same as doing, instead of the full interest expense, saying, well, it's the net interest expense, but if it's IFRS, then the expected return and the interest expense are the same. If it's GAAP, well, then they're different. I'm going to show you that it really doesn't matter. So if we take interest expense and expand it out to the way the formula is written in the book, the more complete, precise formula, we have net interest expense, or net interest income. It's the interest expense minus the expected return on plan assets. If it's IFRS, these two are the same. So we just take the net pension asset or the net pension liability and multiply it by the rate. If it's GAAP, we have to take interest expense on the full PBO, expected return on the full assets, and take the difference. And our actual return, if we're looking at it in terms of being very precise, it would just be the difference in the actual return over the expected return. We would take our actual return minus our expected return. Now let me prove to you that this is the exact same thing. Let's say our interest expense was 10 and our expected return was 8. So our expected return is 8 down here, and let's say our actual return was 9. Well, what do we have here? We have interest expenses of 10 minus expected return of 8, so we have an expense of 2. Here we have an actual return of 9 minus an expected return of 8. We did better, which means we have 1 of income. Net result is we have 1 of expense. Well, if our interest expense was 10 and our actual return was 9, 10 minus 9 is 1 of expense. There you go. It's the same thing. This is just expanded out, but the terms cancel and you would end up in the same place. So if you don't want to get confused between IFRS and GAAP and you're looking for the total periodic pension cost, regardless of what statement that it was on, this is all you really need to know. Next, the p-value. This seems to cause candidates a lot of trouble. P-value, this is just an alpha. Think of it as just alpha. So if we're testing alpha at 0.05, the p-value is 0.05. So any p-value we get greater than 0.05, we do not reject. In other words, it's not significant. If the p-value is less than 0.05, we reject because we have significance. That's all we're doing. If we're testing at 5%, we would reject the null hypotheses for anything less than 5% out in the tails of the distribution, right? Well, that's all a p-value is. So if we're testing at 1%, a p-value greater than 0.01 means we do not reject. It's insignificant, which is this one here. A p-value less than 1 means we can reject the null. We've found something significant. The p-value tells you the smallest level of alpha at which you can reject the null. So if we have a p-value equal to 0.136, that means that we can reject the null if we were testing at an alpha of 13.6%. Well, we would never test at an alpha that high. That's simply just too high. If we have a p-value of 0.0001, that is telling us that we can test at an alpha of 0.01% and still reject the null. Not 1%, but 0.01%. So the p-value is just a really quick way for us to look at the value and say, well, that is the alpha that we would have to use in order to reject the null. 13.6% is simply too high. We want alpha at 5% or alpha at 1%. So if I give you a p-value of 0.026 and I ask you, can we reject the null if alpha equals 5%? You can say yes, because 2.6 is lower than 5%. So we can reject the null. We have significance. If I ask you if we can reject the null if alpha equals 1%, well, the answer would be no. 1% is more stringent than 2.6%. That's what that 0.02 is telling us, is that alpha, we can reject at alpha of 2.6% or higher, but not lower. So if alpha were 2.5%, well, too bad. Our p-value is 2.6. That's the lowest p-value, the lowest alpha we can reject. So we could reject the null at 5%. We cannot reject the null at 1% because our p-value is 0.026. All right, next popular question, t-tests and critical values. In my videos, sometimes I look down a list of autocorrelations and I look at the t-stats and I say, okay, well, none of these are significant. And I get a lot of questions of how can you tell you didn't look up a critical value? You don't have to. As n gets large, the t-distribution approaches the z-distribution. So at 5%, which is what all tests are done at in statistical output, 5%, the critical t-value approaches the critical z-value of plus or minus 1.96%. So t-tests less than 1.96% are insignificant. So if I'm looking down a bunch of autocorrelations and I see 1.368 under the t-stats, 1.842, 0.096, on and on, well, these are all less than 1.96. None of them are significant. T-tests greater than 2.3 on average will be significant. It would be difficult to have a critical t-value greater than 2.3. And let me show you what we have here. Here are different values of n, 10, 30, 100, and 200. At n of 10, the critical value is 2.228. So if we see a t-test and it's 3.68, I don't even need to look up a critical t. 3.68, that's going to be significant. Now, if I have a sample size of 50 and I see a t-value of 2.10, at that point I'd say, well, maybe I need to look that up. But look, at 30, you're down to 2.042. So if your n is greater than 30, you can take 2.05 as your cutoff right away. Anything over 2.05 is significant. Anything under 1.96 is insignificant. It's just the closer you get to 1.96, the more you have to find a critical value. If our n is 100, we're at 1.98. If our n is 200, we're at 1.972. The t-value can never get lower than 1.96. As n gets larger, this t-value will continue to shrink until it hits 1.96. So all you have to do is look at your n. If your n is like 227, you could say, well, okay, well, 1.96 to 1.98 will be roughly around where my critical t-value is. Anything under 1.96 you can automatically assume is insignificant, because a critical t-value can never be less than the 1.96. So there we go. Number 6, currencies. Give everybody a hard time, and I'm just going to draw a line right here to separate the two thoughts that I have. There we go at the bottom of the screen. Domestic over foreign, foreign over domestic, indirect, direct quotes. It's hard to keep it all straight, and I'll agree. Currencies are that one thing where it slows people down and you have to stop and think about what you're doing. There is only one thing you need to remember about quotes, and they're all in the form of P/B. The other thing to keep in mind is CFAI uses them as a fraction, not as a quote that you would see in the marketplace. As a fraction, which means the denominator is always 1. So if you can remember price over base and the denominator is always 1, all quotes work that way. Now, instead of thinking in terms of price and base, you can think of it in two different ways. You can think of I want over I got, or I got over I want. And it doesn't matter which way you do it. I'm going to show you how simple this really is. If you're going from the upstairs to the downstairs, in other words, you're going from the numerator to the denominator. In other words, you're going from something you got to something you want, or from something you want to something you got. If you're going downstairs, you divide. If you're going upstairs, you multiply. Let me show you how straightforward this is. Let's say I have 10,000 Canadian. So what do? I got 10,000 Canadian. Let's work with the first one right now. Let's work, we'll work with this one, the I want. So I want US dollars. So I got what? CAD. I want what? USD. There's the quote I'm looking for, CAD USD. I go in the market, I find 1.345. What am I doing? I'm moving from the upstairs to the downstairs. So what I'm going to do, I'm going to take my 10.5 divided by 1.34. That's how much US I get. 10.5 divided by 1.345, I get 7.345. Now I don't have to go from upstairs to downstairs. I can get a quote in the form of this. So now, when I look at this particular quote, I say, well, what do I got? I got CAD, I want US, so what do I got to do? I got to go upstairs. If I'm going upstairs, I multiply. There's my quote, 7.345 times 10,000. There's how much US I need. Just remember, everything is in the form of price over base. The base is always equal to 1. CFAI uses them as fractions so that the multiplication and the division are super easy. You can think of quotes in terms of I want, I got, or I got, I want. So all you have to figure out is, what do I got? Let's say that you're a US investor and you're investing in Canada, and in 6 months you're going to want to bring that money back. Well, what are you going to have in 6 months? You're going to have Canadian. So you got Canadian, you want US. You can look for this type of quote, or you can look for this type of quote. And just remember, if I got and I want, and I have to move downstairs for it, I got to divide. If I got and I want and I got to move upstairs for it, I got to multiply. That's it. And number 7, probably one of the most frustrating concepts is, when do I use simple interest and when do I compound? Because sometimes I see taking a rate 0.12% and then you're multiplying it by 90 over 360 and then adding the 1 to that after. When do I know to do this, or when do I know to go 0.012 to the power of 90 over 360? What makes this a little bit tricky to explain, I'm not going to say tricky to explain, but what makes it kind of more difficult to explain is there are some authors of some content in the market, and I've seen it in textbooks, that do not even know themselves when to use simple interest and compound interest. And you have some authors that will compound absolutely everything, and it's wrong. Money market rates, simple interest only. So let's say that we have a 181-day deposit. Well, that's simple interest. Why? Is because it's only for a period of time and that's it. There is no compounding opportunity. It is only for that period of time. Single period investments or single period contracts, a 90-day FRA. There is no compounding during that period of time. It starts and it ends and that's it. So simple interest only. And in instruments where there is no compounding opportunity, for example, swaps, if you have quarterly resets or semi-annual resets, well, there is no, you don't reinvest back into the swap. There is no reinvestment into it. It's simply just the interest for that period, and then you go off on your merry way, and that's it. So if you can remember those rules: money market rates, simple interest, single period investments or contracts, simple, and no compounding opportunities, use simple, and use compounding for everything else. If you're in doubt, for the most part, about what to use, if you're solving problems in derivatives, always default to simple interest. You can't go wrong in derivatives. If you're doing something with currencies, currencies are based, the interest rate on currencies are based on bank deposits based on I believe it's an actual over 360 year simple interest. If you're in other areas where it's, let's say, equity or alternative investments and you're present valuing some future amount, then use compounding. It is just a shame that there isn't a better treatment, a more consistent, I shouldn't say better, a more consistent treatment of this particular topic across all textbooks in this industry. But I've seen some that just compound everything no matter where it is, and then others will make the distinction, and you're left wondering, well, what's the rule? Because neither one of them really describes what the rule is. Well, I hope that helps.